Hey guys! Welcome back to my channel. In this video, we're going to be talking about what linear inequalities are and how to solve them regularly and as a system of linear inequalities. Let's get started. So the first thing we're going to learn is the symbols that are used in linear inequalities. So there are four symbols that are used. We have 1, 2, 3, and 4. Each symbol has its own meaning. For instance, the first symbol means less than. The second symbol means greater than. The third symbol means less than or equal to. And the fourth one is greater than or equal to. Now that we've reviewed these concepts, let's move on to seeing what a linear inequality looks like. Say we have a linear inequality, something that looks like this. 3x plus y is less than 2. So 3 times x plus whatever y is should be less than 2. That's what this inequality is saying. So to solve this inequality, we want to solve for the y variable. First of all, to get it into slope-intercept form, we're going to subtract 3x from both sides, and we're going to end up getting y is less than 2 minus 3x, or to make it look a little cleaner, we can say y is less than minus 3x plus 2. So now that we have our linear inequality in slope-intercept form, we're going to want to graph this inequality just as we would graph an equation in slope-intercept form, but with a few differences. So the first thing we're going to want to take note of over here is our symbol. So what we're looking at this symbol for is if the symbol was either less than or greater than, that would result in a dotted line on the graph. But if the symbol is less than or equal to, or greater than or equal to, the symbol would result in a solid line on the graph. So looking here, we can see that our symbol is a less than symbol, not a less than or equal to, which means that we're going to have a dashed line on the graph. So now we're just going to graph this like we would normally graph an equation. So we have y is less than negative 3x plus 2. So negative 3 is our slope and 2 is our y-intercept. So I'm going to start at our y-intercept right here, and I'm going to go down 3 and to the right 1. And I'm going to get one more point, so I'm going to go down 3 again, to 3 and to the right 1. So now I have about 3 points right there, and now I can draw a line connecting these 3 points together. Now when I draw the connected line, as I said before, the lines are going to be dashed, not solid. Here is our dashed line. Now from here, of course we can't just draw a line because this is an inequality. So while we're graphing our inequality on the graph, we want to be able to see where all of our valid solutions are. So over here it says y is less than negative 3x plus 2. So all of our solutions are going to be below the dashed line because our solution set should be below the line negative 3x plus 2. So we're going to shade in everything below this line, and that is going to be our solution. Everything below the line on that graph is going to be our solution. And yeah, that's it. That's our solution. Say we have an inequality that's something like this. This inequality says 4x minus 5y is less than or equal to 15. So we should get right on with solving it, and remember the first thing we need to do is convert this into slope-intercept form. So this is going to be the inequality that we graph. So remember, before we start graphing, we need to look at the symbol to determine whether our graph is going to be a dashed line or a solid line. So over here, our symbol is less than or equal to. Remember, anything with the equal to at the end means that we have a solid line. So let's move on over here to start graphing this. Our y-intercept is -3. So we're going to start at -3, and then our slope is 4/5. So we're going to rise 4, 1, 2, 3, 4, and we're going to go over 5. 1, 2, 3, 4, 5. So that's around right here. And so 2 points is good enough to draw a line. So let's connect these 2 points to get our line. And remember, it's going to be a solid line. So here is our line. From here, we need to shade the graph to get our answer. So it says y is greater than or equal to 4/5x minus 3. So all of our solutions are going to be above the line 4/5x minus 3. So this line right here is our line, and all solutions should be above this line. So we're going to shade everything on the graph that is above this line. And so that is going to be our answer, everything above the line. Now, another thing to note is that on the graph, when you see a solid line, that solid line means that all points on that line, as well as everything above that line, are solutions. If you remember the previous one, we had dashed lines. So those dashed lines mean that only things above the line are solutions. The actual points on the line itself are not solutions. So this is our final solution to this linear inequality. Now let's work on linear inequalities as a systems of equation. So let's say we have a system of linear inequalities that looks something like this. So this one says x is greater than or equal to 3 and y is greater than -2. How we're going to start to go about this is we're going to do the exact same thing that we've already been doing. So we're going to graph x is greater than or equal to 3, and we're going to graph x is greater than -2 on the graph. And we're going to shade in the respective areas that contain the solutions to those two inequalities. So here we have our graph. Now our solution is only going to be in those areas where it's shaded both red and blue, so where the two shaded regions intersect. So looking closely, you can see that there is this one region where both the red and the blue overlap. I'm going to shade it in purple. So over here, this one region that's in purple is our solution because it's above y is greater than -2 and to the right of x is greater than or equal to 3. So that's going to be our solution. And to clarify even further, the line y is greater than -2, nothing on that actual line is going to be part of the solution. But for the line x is greater than or equal to 3, that line itself is going to be part of the solution. So this is going to be our final answer for this one. Let's solve a final linear inequality. This system says 5x plus 3y is less than or equal to 12, and minus x plus 3y is greater than or equal to -6. Now remember, the first thing you need to do is convert both inequalities into slope-intercept form. And then graph both inequalities on the graph and shade the appropriate regions. Now, as a systems of inequalities, we're trying to find where both of the regions intersect or overlap. So looking to the very left of the first line, that was about right here, and right above our second line was about right here. So everything in between these we can see is yellow and green. So everything in this region right here is where the two lines intersect. So this is going to be our final solution to this one. So that's it for today, guys. I hope everything was clear and easy to understand. If you have any questions, please drop them below in the comment section. If you want more videos like this, please like and subscribe. Thank you so much for watching. See you next time. Bye!